Objective 5, use the reactivity of metals or halogens along with the metal or halogen ion to determine if a reaction occurs or what we call spontaneous. So a spontaneous reaction are usually exothermic reactions. You don't have to put energy in to make them occur. They'll just happen on their own over time. Sometimes short amount of time, sometimes much longer process. So HBr plus Cl2, what you have to realize is Cl2 is the non-reacted. It's in its pure form, so it's non-reacted, and the Br has reacted. So the question is Cl, is chlorine more reactive than bromine? And to find that out, you look at a periodic table and you look at the halogen family. And fluorine's the most reactive at the top because it's the tiniest taker. And as you move down, then chlorine is second, and then bromine, and then iodine. So yes, this reaction would happen. And if you had to write the reactants, so let me put the yes over here, it would mean you'd end up with HCl and Br2. So then I'd balance it with a 2 here and a 2 here. With metals, it's not quite so cut and dried when you look at the periodic table, although in general the most reactive metals are in the lower left, but there's some other factors that come in. So you're given a metal reactivity chart. I think it's table 25 in your booklet. So when you look at zinc and nickel, they haven't written what nickel is combined with, what ionic compound it's in, because it's in an aqueous solution in order for these to react. But the question is the zinc metal more reactive than the ion? Because the zinc metal is the unreacted metal, and this is the reacted metal. And the reason I know that is because the zinc has not given its electrons away, whereas the nickel has, which is why it has the +2 charge. Same is true of the first one. The Br minus has given its electrons or taken electrons from another species, whereas the Cl2 is only bonding or sharing with itself. So when I look at the reactivity chart, I see that zinc is more reactive than nickel. So I could expect zinc to give up its electrons and force nickel to take them, and the following reaction to occur. So halogens tend to take electrons, and to determine the reactivity, you look at the halogens family. And again, when you look at the family, fluorine being the smallest is the tiniest and most able to take, and then it just goes in order as you come down the family: fluorine, chlorine, iodine, and bromine. Metals tend to give electrons, and you need a reactivity table, or you'd have to actually do an experiment to be able to determine metals. But generally, the lower left is where your most reactive or largest losers are located.